Hey, it's time for an update on our CNC router from Acmer because there is a lot. We got into 3D carving even before all the upgrades arrived, but now with everything here, it is mind-blowing what even a budget machine like this can do. At least for a 3D printing enthusiast like me. So today we'll do a surprising amount of 3D printing on 3 of our printers, but also tell you about the new bits, the upgraded spindle, the dust monster, and the complete carving process utilizing the free-to-use version of Fusion 360. Yes, we did figure it out.
So, this is gerGO.
And this is Levi from gerGO Print 3D.
The YouTube channel where this nephew-uncle duo discovers 3D printing and related technologies. We do fun projects with our fleet of 3D printers, various lasers, and now even this entry-level CNC, kind of working our way backwards to the roots of the industry. Enjoy this episode with our usual translation-ready subtitles, detailed chapter markers, and audio tracks in 20+ languages, maybe yours too. Before we dive into the upgrades, I have to say this video again is sponsored by PCBWay. We are about to spend this whole video pushing this desktop machine to its absolute limit, but let's be real, sometimes DIY just isn't enough. When you need parts that are harder, tighter or stronger than what we can make at home, like this custom stainless steel piston they machined for our chocolate printer, you need a factory. PCBWay is famous for their $5 prototyping PCBs with 24-hour turnaround, but for us makers, their industrial CNC and 3D printing services are just as attractive. So, if you have a project that is too big or too complex for your home workshop, simply upload your file to them, pick the material and finish you need, and get an instant quote. Their experts will work with you to help bring your ideas to life. In our recent video, we showed how they actually advise us on the material and whether to include modeled threads in our design. And what they delivered was perfect. Support the channel by clicking our affiliate link in the description below to get your next project started right. A couple of months ago, we showed you our first impressions with the Ascarva 4S. Those first projects were simple, but they were enough to get us hooked. At the end of that video, we promised to push the limits with new bits, a stronger spindle, dust collection, and the holy grail, 3D carving. And boy, did we get far. But here's the thing. You don't need to wait for upgrades to start making cool stuff. Before any of the heavy metal arrived from China, we wanted to see what the stock 70-watt motor could handle. Step 1 was getting away from the simple V-bits. We hopped onto AliExpress and grabbed 2 specific types of cutters. Standard 1/8" flat-end bits to chew through the bulk of the material during the roughing phase, and 1/8" ball nose bits to smooth out the organic curves during the finishing pass. I've put links to both in the description below, and naturally, since we are a 3D printing channel, we couldn't just leave them loose in the drawer, so we printed a custom bit organizer to keep everything tidy. We started with this model from Dave D on Printables, added the channel name, and printed on the Creality K2+, we made 2 color changes to match the color scheme of the Ascarva. For the software, we stuck with Easel for these first tests. The 30-day pro trial was still active, and honestly, for beginners like us, it's incredibly intuitive. After a few small test projects, which got progressively better, we finally loaded up the 3D model of this hunting dog, and Levi's choice, Pikachu from Pokemon. Now looking back after using the big upgrades, I have to give credit to this little 70-watt spindle. It's definitely not a toy. It got the job done, but the process looked like this. Without a dust shoe, the chips go everywhere. Levi was on manual extraction duty for the duration. He kept going back to the machine every hour or so to reveal the progress from under the new pile of dust. You also cannot see my laptop hooked up because we utilized the SD card instead. This removes one major fail point. We don't need to worry about USB connection loss, the computer going to sleep, or Windows starting an unwanted system update right in the middle of a carve. Running the job from the touchscreen and the SD card solves this all. 3D carving requires changing tools mid-project, which introduces a problem. Since we have to move the tool head to swap the bit, we lose our physical position. And since the controller tends to forget the software origin between jobs, we needed a fail-safe workflow to ensure the finishing pass lands exactly on top of the roughing pass. Here is the workflow we used. Select the NC file for the first job on the device screen, home the tool head, find the surface for the Z height probing block, one that is not going to be carved away, and navigate to it using the on-screen controls. Jot down these coordinates. This is crucial. Attach the wire to the bit and probe for Z height. Touched and slowly touched. Now, still using the on-screen controls, navigate to the starting point, the job origin. Jot down these coordinates too before selecting set XY0. Start the spindle, optionally turn on the tool headlight, and you can start the carving job. The first pass is loud and slow and messy, but it is exciting to see all that material extracted. When it's time to change to the finishing bit, we use those coordinates we wrote down. This ensures the probing happens at the exact same place on the block, and the finishing pass starts at the exact same job origin. The second pass is much more precise, grazing the surface with the ball nose bit at a much higher resolution. In case of this beautiful Hunter dog plaque, we even repeated the finishing pass from a different angle for maximum surface quality. And since our first passes did not reach all the way to the back, we changed back to the flat end bit to plane away the back side.
And you can use a screwdriver or something to lift it up.
Both the Pokemon and the hunting scene came out looking more than great. They are just amazing. And Levi is right to be proud of them. And I'm sure you are impressed with the progress already. But before upping the ante, please express your excitement with a like and subscribe to help us reach as many viewers as possible. Thank you if you did. This result proved that even with the stock motor and cheap bits, if you are on a budget and have the patience to let the machine run slower and maybe hold a vacuum cleaner for an hour, the Acmer Carva 4S is already capable of true 3D relief carving software wood right out of the box. But as our easel trial was expiring, we knew we could make it faster, quieter, and much cleaner. And then the much anticipated upgrades arrived. First up, we had to solve the mess.
Unboxing.
As you can see from the footage, Levi was very excited to unbox the Dust Monster, and yes, that is actually the official name on the box.
We can see.
The 2-3's Dust Monster is not specifically made for the Carva 4S, but we hoped it could be fitted. The dust shoe that first came out of the box is a pretty complex component actually. It has various size mounting options, strong magnets, and a row of LED lights. But did you know this thing even has a microphone in it? That's how it knows when the CNC is actually running, so it can turn on automatically. We also get a regular size nozzle for general cleanup, a circular brush for sweeping and keeping the dust in the suction area, an external 3 amps power adapter, and the main event, the Dust Monster itself with the corrugated hose and 2 dust bags included. But there was a moment of panic during the unboxing.
There is one thing missing when gerGO checked there. So you can see this is the 50 millimeters brush. It turns out there is a 20 millimeter too, but it's hiding so well you can't see.
Don't throw it out with the box.
Yeah.
We make mistakes, so you don't have to. The shorter brush is actually the one we will use with our standard 1/8" bits, so finding it is crucial. The installation was surprisingly straightforward. The screw holes match the holes on our 70-watt spindle, so if you are looking for a solution for dust extraction, this is an easy recommendation from AliExpress for around 70 euros, link in the description. We installed it, but did not even have a chance to test the vacuum with a real project, because right on cue, the Spindle Upgrade also arrived.
Oh hey! We get another box from Acmer.
Acmer, yes.
This is the stronger motor for the CNC and we can unbox it.
Last time we were looking for all kinds of options on AliExpress, but Acmer just upgraded us with the official 500-watt DC motor, so we don't even have to worry about compatibility now. Why did it come in such a big box though? You'll see in a sec. But have you noticed our upgraded unbox technique? That's thanks to HW+SW. We are testing their edge flow cordless electric scissors. It's great for fabrics, blister packages, leather, carpets, and yes, for cardboard too. We found it most practical for preparing large boxes for recycling. Get yours with a 15% discount using our code gerGO from hottooltools.com. We double checked and did not forget the instruction leaflet in the box either. We'll need it. And this is, whoa, this is like 3 times as big.
How many times is it gonna be faster?
That's the big question. Is 500 watts really more than 7 times stronger than 70 watts? We were stoked to test. Besides the spindle, it's bracket, power and data cables.
And what is that? It's a new power supply.
I like it.
Did we get a power cable for that?
No.
Turns out we are supposed to use the same standard power cable that came with the base machine.
Compare the size. It's like
2 times bigger.
not only longer, but thicker.
Yeah.
Thicker.
Replacing the original motor was a breeze. Even the dust shoe fit the new spindle, but with a small catch. We had to add a couple of washers to prevent it from snagging the bottom edge of the tool head mount. Greg from the laser channel warned us about reverse polarity on his unit. It was spinning in the wrong direction for him. We plugged it in, and as you can see on our slow-mo recording, it is spinning the right way without the need for modifications. There was one last problem to solve using, once again, 3D printing, but we did not realize it at the time, and that caused some trouble. For now, before we could actually use the faster spindle, we had to update the firmware setting to utilize its higher RPM. For this, we updated the setting, $30 equals 12,000. In the GRBL settings table, this tells the controller our new max RPM. With the new motor and the vacuum installed, the hardware was finally ready for the big league. Now we needed a similar upgrade for the software as well. With the easel trial expired and having no intention to pay hundreds of dollars annually, we first looked into FreeCAD. Version 1.0 is supposed to make it much more accessible, and the developer himself demonstrated its CAM capabilities in a YouTube video. Our test project was this cool lion head from Call3D. However, it turned out to be way too complex. It locked up our very capable 64GB 12th Gen Core i7 computer even after multiple rounds of mesh simplifications. That escape path fallen, I had to bite the bullet and learn CAM in Fusion 360. Now, Fusion is home turf for me when it comes to CAD design, but the manufacturing workspace still felt overwhelming. However, with the help of an AI assistant, I did finally manage to make sense of all the settings, and I have compiled them here so you don't have to guess. Here is the workflow we came up with. First, import the STL. You don't even need to convert it to a solid body. Next, draw a cutting shape like an ellipse around the model to define your boundary. Then switch the workspace to manufacture. In the manage group, set up your machine. You'll be able to pause the video to copy as I page through my specific settings for the Ascarva 4S with the 500 watt spindle. Under manage, we also add the 2 bits we'll use in the tool library. First, a 1/8 inch flat end mill. The cutting speeds you see here, 1300 millimeters per minute feed rate and 1.58 millimeter step down, came after some experimentation with relatively soft pine wood. Second, the 1/8 inch ball nose bit. Here we can feed slightly quicker at 1800 millimeters per minute, but with a pretty low 0.25 millimeter step over to get the best smoothing accuracy. The good news is you only have to set the machine and tools once. But even the rest of the setup I'll show you next can be reused for future projects if you replace the model and the vector shape and save it under a new name every time. When setting up the job, the key is the stock. This depends on your actual piece of wood. The trick we found was to use stock no thicker than the cutting length of your bit, but a few millimeters thicker than the height of your model. Then position your model 1-2 millimeters offset from the bottom. Then we'll set up 3 distinct jobs: roughing, finishing, and cutting. Important tip: we precede each job with a manual NC command. This adds a specific G-code line to raise the tool head a bit over the top of the stock. This prevents the bit from scraping across your beautiful wood surface as it travels from the home position to the starting point. The roughing pass in Fusion is called 3D adaptive clearing. We select the flat end bit for this. We set the optimal load, which is Fusion's term for step over, to 1.27 millimeters, about 40% of the bit diameter. Be sure to set stock to leave to 0.5 millimeter. This leaves a tiny layer of wood for the finishing pass to clean up. Most of the values come from our tool presets, but be sure to copy the rest of our clearance, passes, and linking values too. The finishing pass is called 3D parallel. We switch to the ball nose bit for this. Copy our settings here, especially the smoothing values, which ensure the processor in the CNC isn't overwhelmed by too much data. For the best effect, we chose a 45-degree pass angle across the grain lines, and we checked add perpendicular passes. This automatically repeats the finishing pass at a 90-degree rotation, a technique called cross-hatching. Turn it off for a quicker, slightly rougher finishing. 3. The cutting pass. Finally, to extract the model, we use 2D contour. We go back to the flat end bit and select that vector shape we drew earlier. Crucial step, check the red arrow. If it's on the inside, click it to move it to the outside, otherwise you'll cut through your model. I recommend slowing down to 1200 millimeters per minute and reducing the step down to just 1 millimeter for safety. Since we are cutting 0.5 millimeter below the bottom to free the part, make sure you have a piece of scrap wood under your stock or you will carve up your spoil board. Always simulate the setup. If it looks good and gives no warnings, right-click each job to select post-process. Since we don't have an automatic tool changer in this machine, I saved the 3 passes as 3 separate files, labeled A, B, and C, so I can run them one by one. Important, before posting, mark both the manual NC command and the job itself on the operation page to include that tool head lift in each of your passes. I demonstrated these settings on this relief portrait of John Calvin, the famous Protestant theologian. I actually got this ceramic piece a while back and 3D scanned it using the Creality Utter Light we got from Geekbuying a while back. It was an easy scan using marker cubes. Watch this video about them if you're interested. We then printed a metallic looking version on our bamboo H2S using ESON gold silver silk PLA with a filament change to Sovol black for the text. This is why we needed to use a multicolor printer. It was a 6-hour print at 0.1 millimeter layer height. It's the same model, same size, but a very different feel from the ceramic original. After our initial success with the small lion head, this was the perfect candidate for our second big carve. The same model from yet another material. You might notice my laptop is hooked up in the footage of these later projects. While we still prefer the safety of the SD card for the actual cutting, I admit that for complex setups, we started to use UGS, Universal G-Code Sender. Why? Because typing in G0, X100, Y100, F5000 gets the toolhead where I need it instantly, which is way less frustrating than tapping the touchscreen buttons 100 times to microstep across the bed. But once the origin is set, I fold the screen of the laptop to protect it from dust and hit run from the SD card. So how does Fusion Cam compare to easel? It is next level. And honestly, once you figure out the settings, which we just did for you, it's not that much more complicated. And the big question, how much faster is the 500 watt spindle? It spins 50% faster than the stock motor, but the real difference is the torque. We were able to triple the step down value while doubling the feed rate compared to the 70 watt spindle, and these are still conservative values. The motion system is still the limiting factor, but a relief of this size in soft pine took about 4 to 5 hours for roughing, 2 to 3 hours for the crosshatch finishing, and about 1 hour for the cutout. It's not mass production speed, but it's roughly on par with 3D printing the same object in multicolor. As for the dust monster, we learned the name is very fitting. It roars like a monster, but it is very effective. The sound-based audio operation worked, but I ended up just keeping it on max power because honestly, there is no downtime in carving anyway. And speaking of noise, remember how we promised a quieter cooling fan upgrade at the end of the last video? Well, we haven't done it. Why? Because next to the 500 watt spindle, the carving bit chewing through wood and the roaring dust monster, that screaming cooling fan is now actually the quietest part of the device. It would only help our sanity during the brief setup section before we turn the motors on. So for now, the stock fan stays and the whole machine is exiled in the furthest part of my apartment. However, at the beginning of the finishing pass on the lion relief, we noticed a massive drop in suction power. And we soon discovered the horrific reason why. The vacuum hose had rubbed against the cooling fan on top of the new spindle. And the spinning fan sanded a giant hole right through the pipe. The fix was easy though. First we patched the hose with duct tape. Then we used our first bodged 3D carve as a temporary standoff to finish the job. As it was running, I jumped into the CAD workspace of Fusion to design a proper solution, this simple 3D printable spacer. It clamps between the spindle and the hose to keep them permanently apart. We needed it quick, so we printed it on our fastest FS on S1 Pro using high-speed Creality Hyper PLA to match the Escarvas colors. I'm publishing this model on Called 3D along with our Fusion 360 Cam setup project file to give you a running start on 3D carving with the Escarva 4S. links to this project and affiliate links to the machine and its upgraded spindle are in the description below. Please use them to support us. It doesn't cost you extra, but it helps keep the lights on in the workshop. What's next? Maybe aluminum. But before that, I have to tell you about the new Sovol device we got. An amazing upgrade for our Tuka L2 laser. A chamber heater upgrade for our Sovol SU8 Max, and so many ongoing projects, it's hard to keep track of them all. If you haven't yet, be sure to watch our initial review of this CNC router in this video, or watch us eat our 3D prints in this fun video here. Let's all go print 3D or carve 3D. Either way, thank you for watching yet another gerGO Print 3D video all the way to its end. Stay curious.